All right, number one, what is an axis? So the axis is the point around which circular motion occurs. So if I got a circle or something like that, or a sphere, however you want to think about it, it's the center point that you rotate around. An axle is the actual object that you'd be going around, so like on a car. But an axis is just the point that you're, it's like the invisible fulcrum, if you will. Yes?
What did you say about inertia and why?
So the reason why it's inertia is because it's moving forward with the bucket. So the bucket is, oh man, here's a really terrible drawing. I only have 3 fingers apparently. There we go. Here's the water. The water is going forward. And so even though gravity pulls it down, it's going to pull it down kind of in a curve like this. And that's the direction the bucket's going. So the bucket kind of catches its forward fall. In other words, it doesn't fall straight down because it's already going forward. If it would fall straight down, it would spill out on me. But because it's going forward, it doesn't. Someone else had a question. No? Okay. So point around which circular motion occurs. Okay, so what is rotation? So rotation is circular motion about an internal axis which, by the way, is this drawing that I did here. And rotation is circular motion about an outside or an external axis. So that would be like, here's an object. Here's an object going in a circle around it. So that's revolution. Okay, any questions on the front for me? Look at us cruising right along. Okay. Deep breath. We got to get through these definitions, but they're just definitions. And then we'll be done with the notes for a little bit at least, and then we'll jump into the lab. So, A, what is linear speed or linear velocity? So it's the straight line speed of an object. Okay? It's what we've done this whole semester. It's just V. It's what you're used to. Nothing funky, nothing new, nothing weird, just straight line velocity. So what is tangential speed? Tangential speed is the straight line speed of an object moving in a circle. Okay, that definition by itself doesn't make a lot of sense, so let me try to explain it. Okay, you're driving around a racetrack in a car, A perfectly circular racetrack, just to make the example easier. Okay? So if I'm in this perfectly circular racetrack or dome or whatever it is, it's how fast forward I'm driving as I'm going in a circle. In other words, it's your speedometer. You've never noticed this before because it's not anything to notice. When you turn, your speedometer doesn't change. If you're on the interstate and you're going 70 miles an hour and you turn, you're still going 70 miles an hour. Okay? It should be different because you're changing the direction you're going in. Okay? But it's not different because we're only worried about how fast am I going forward as I'm turning. Okay? So it's what your speedometer tells you. So it's the straight line speed of an object that's moving in a circle. So the only difference between linear speed and tangential speed is tangential speed is specifically objects that are moving in circles. How fast are they going? Okay? So this is how fast do you go as you go around in a circle. All right, what is rotational or angular speed? It is the speed of rotation / revolution around an axis. These two are measured in meters per second. This one is measured in rotations per second. This one is not how fast are you going. This one is how quick do you rotate. Okay? Think about like a ballerina or an ice skater. It's not how fast do they go down the ice. It's how fast do they spin around. Okay? Tangential speed is how fast do they go down the ice as they're going around in a circle. So if they're curving around the ice, how fast are they going? The rotational speed is how fast do they do their spins. Okay? If I'm going back to the car example, this is how many laps does it make per second? Not it's going 50 miles an hour. So maybe it's going, 1 lap per minute, but it's going 200 miles an hour, whatever the case may be. Okay? Okay, how are tangential speed and rotational speed related? Here's the equation. V equals R omega. So V, by the way, is linear / tangential velocity. R is radius. And this funky looking W thing is the Greek letter omega, and that's rotational speed. So all you have to do to get them to be each other is either multiply or divide by radius. Okay? Okay, what is tangential acceleration? How quick you change your tangential velocity. So that's speeding up or slowing down. And lastly, centripetal acceleration. Centripetal acceleration is the acceleration caused by a change in direction. And it is always towards the center of the circle. So centripetal acceleration is your acceleration that's caused by your changing direction. Okay? Remember, acceleration is a change in velocity. Velocity is magnitude and direction. The key to this unit is you're changing direction, and that makes us accelerate. The name of that acceleration is centripetal acceleration. So if I'm going to draw a diagram of all this stuff, okay, if I got some center axis, but I should write the word correctly. There we go. I got some center axis. I have an object. It has a tangential velocity forward. It has a rotational velocity around the circle. And it has a centripetal acceleration in towards the center. And the symbol we use for that is just AC. I'll zoom in a little bit. I'll make that kind of small. Okay. Yes, ma'am?
Oh, I'm sorry. What's the three little circles? Or is just...
This here?
Mm-hmm.
So this is AC. I just didn't draw them very well. So it's centripetal acceleration, AC. And again, while I'm going to call this tangential velocity, this unit, it's no different than what you've done already. Okay, it's no different. It's distance divided by time. The distance is how far I'm traveling forward. The time is how long it takes to do that. So nothing really that wild and crazy.